Today we are going to discuss ray optics topic, in that refraction, that is refraction through the plane interface. Generally, refraction will be through the plane interface and also through the curved interface. Both will be there. In this curved, again, convex interface, concave interface. Okay, so for all this, a common formula will be there. The formula will be equals to mu2 by v minus mu1 by u equals to mu2 minus mu1 divided by r. So how this formula is arrived, actually it is due to Snell law. Okay, from Snell law we will derive this. Okay, so the derivation is not given in this class. Okay, so we will consider the direct formula here and we will see how to apply for plane surface, plane interface, and also for curved interface. Okay, so let us go into the first, the easiest part is going to be plane interface. Okay, generally for NEET level problems they will ask you in the plane interface cases only. Okay, so the difference between plane interface and curved interface mathematically is very simple difference. It is, for plane interface the radius of curvature is infinity. Okay, so the formula turns out to be, that is mu2 by v minus mu1 by u equals to mu2 minus mu1 by infinity. So you know that something by infinity equals to 0. From here we can rewrite this mu2 by v equals to mu1 by u. Otherwise we can rewrite this, v equals to mu2 by mu1 into u. Okay, so here what are mu1 and mu2s? Like, there are refractive indices of the two media which are separate, which are on both sides of the interface. Okay, so mu1 generally the refractive index of the medium in which the incident rays are lying, and mu2 is a refractive index of other medium. So let us consider one example, or just let us consider this case. So let this be the interface which is separating the two medium. Okay, two media, and an object is considered here. Definitely from this object the light rays will diverge. Okay, this is what actually real object, we can say it is a real object, right? So these light rays, whenever they go from mu1 medium to mu2 medium, here I am considering mu1 should be less than mu2. They are going from rarer medium to denser medium. Okay, so this one, middle one, if you consider, it is having angle of incidence 0, so angle of refraction also 0 according to Snell law. It will go undeviated. Okay, so from Snell law it is I 0, so R also 0, it will go undeviated. But if you consider these two and remaining rays, of course there are infinitely many rays will be there, but only 3 I am considering. So here at the point of incidence we should consider the normal, and actual path of the light ray will be this one. From the one of the properties of light, if the medium change was not there, then this light ray has to follow this dotted path. But because of the medium difference, it is bending, its path is deviated. That is what actually refraction. Okay, so towards which side it is bending? It is towards the normal. Why it is going towards the normal? Because it is a property, when it is going from rarer to denser, it will bend towards the normal. Okay, so that while deciding the image we should concentrate on either incident rays or either reflected rays or refracted rays. Okay, so here refracted ray, elongation of this refracted ray back will intersect this line over here, so probably this is the image. Okay, and same thing happens here also. So let me draw here. The actual path is this, but it is deviated towards the normal, and if you elongate this back, it will meet here. So this is virtual image. From the definition of real and virtual images, this is going to be virtual image. And here you can say clearly the real object distance, if you consider as u, then image distance is v, which is greater than u. You can notice that. Okay, so and that is obvious from here. Okay, because mu2 is greater than mu1. Here I have already mentioned this. So this will give you mu2 by mu1 into u, which is greater than u. That means what? If the real object in rarer medium and it is being watched from the denser medium, then image distance will be larger than the object distance. That is how it happens. And the difference in the image distance and object distance, it is going to be shift. It is called shift. Okay, and how much shift is there? The shift symbol is x. That shift equals to image distance minus object distance. So v minus u is going to be mu2 by mu1 minus 1 into u. This is going to be the shift. In most of the books, they will consider denser medium divided by rarer medium as mu. So this formula will turn out will be equals to mu minus 1 into u. This is the shift formula. And like this, there are 4 cases. This is the case 1, where the real object is placed inside the rarer medium. And the case 2 will be there if virtual object is placed inside the rarer medium. Case 3 will be if real object is in denser medium. Case 4 will be if virtual object in denser medium. Okay, so like that there are 4 cases. Okay, so I'll give you shortcuts to how to remember this, these 4 cases also. I hope you are getting this. Yeah. So let us see the next case, that is if the virtual object in rarer medium, that is case 2, virtual object in rarer medium. Yeah. So virtual object, how to form actually? Virtual object means the incident beam is going to be converging. Incident beam is convergent. That means if there is an interface, this is interface, okay. Suppose the incident beam is like this. Is going to converge somewhere. Okay, so this point is a point of convergence, and this is going to be virtual object. Okay, and the virtual object to be in rarer medium, we want the condition. So this is mu2 we will consider, and this is mu1. Mu2 should be less than mu1. Okay, so if you consider with that notation, whenever it is going from denser to rarer, because mu2 less than mu1, so this is rarer, this is denser. Whenever the light ray is going from denser to rarer, it has to bend away from the normal. Okay, so normal drawn at the point of incidence is this. Okay, away from normal means this one. It will go like this, and here also normal is this. Away from normal means this one. Okay, so they will intersect here. So the shift is going to be this one. So this image is real image. If virtual object is there, then real image will be formed. Okay, so as usual, the object distance we will be provided. This is u, they will give us. Okay, image distance is v. Okay, here again v equals to mu2 by mu1 into u if you apply. Then mu2 is going to be this one, which is less than mu1. So V equals to, according to our definition, that is denser by rarer as mu, if you consider, mu2 by mu1 will be 1 by mu times the u. So it is very clear that V is less than u. That means the image is at lesser depth than the object. Okay, so here the shift is going to be, shift is equals to image distance minus object distance, which is equals to 1 by mu minus 1 into u. This is the shift. Clear? I think you have understood this. Yeah. So we'll consider the remaining two also, like a shortcut I can give you. This is going to be real object in denser medium, like I have to take this. Real object, there are two possibilities for this, and of course virtual object in denser, in rarer medium, in denser medium. This is also in rarer medium, in denser medium. Okay, so what we are going to examine here, you know, first of all, nature of image, okay, and then image distance, and after that shift. Okay, so we have already discussed in case 1, when real object was placed in the rarer medium, we got virtual image. Okay, and the image distance is larger than the object distance, so V is equals to mu into u. Okay, and we have already seen that if virtual object is in rarer medium, that is going to be image distance, image is going to be real image we formed, and image distance is less than the object distance. Okay, so V equals to u by mu. And now if real object is in denser medium, it is going to be, if real object is there, then it is going to be virtual image. Okay, and if virtual object is there, then it is going to be real image. Okay, and in this case it is going to be, image distance is going to be 1 by mu times the object distance. The proof will be similar like what I proved. Okay, and here it is image distance equals to mu into object distance. Okay, shifts is very simple, shift is equals to mu minus 1 into u, here 1 by mu minus 1 into u, here also 1 by mu minus 1 into u, and this will be mu minus 1 into u. Okay, so this chart can help you. Remember, if the object is real, the image is going to be virtual. If object is virtual, image is going to be real. Okay, so